Webinar. Yep, perfect. So I'm going to be talking about mastering numbers today. So there is a large focus on number and particularly early number concepts. I'm going to run through a few different ones. By no means all of them, but I've chosen several that we can kind of cover in this first hour. So, okay. All right. So what we're going to be looking at today is we're just going to be doing a quick look at some of the data. It's a very, very quick reveal for that. We're going to be looking at some early number concepts. So with a focus on counting, subitizing, and place value only. And, you know, it does obviously go beyond that. And I wish I had more time, but I've only got an hour and I've tried to jam pack as much as I can in that hour. I'm going to look at some common misunderstandings in this. I'm not going to sort of focus directly on that, but I'll weave some of those into the narrative of this presentation and also some practical strategies. So I do have some activities for you today. Unfortunately, a lot of what I do is usually in-house and in-person workshops. So a lot of them are very hands-on. So I'm going to do my best to try to walk you through those as much as I possibly can. All right. So first up, let's look at what the data says. So I'm going to comparatively, I had a look at some of the issues around numeracy in India, and I compared it to Australia. And interestingly, it was very, very similar. So this was from the ASER 2024 report. I'm not going to read through that because, you can all see that and you can read through that yourself. But compare that with Australia, and you can kind of see that there are those general struggles. And if we went beyond ASER and beyond NAPLAN and beyond PISA, we would see that even with anecdotal evidence within our classrooms, that these gaps within number concepts, things like place value, arithmetic, mental computation, all of those things are a real struggle for students, as well as problem solving, reasoning, and all of those different proficiencies as well. So really across the globe, all of our students have a very similar problem, which means that we really need to think about what is the underlying factor here. And there has been a lot of research that's gone into this, and we're going to just try to talk through some of the learnings that I've discovered over the years throughout my work in education, and particularly maths education, and see if we can make some discoveries together in this session. So the very first thing that I'm going to talk you through is this is the very first thing that students, or one of the very first things that students learn when they're learning about numbers, is obviously counting. So a lot of kids start learning how to count before they even enter school. A lot of it is potentially rote or memorization, or just like that pattern recognition and pattern building in terms of sequences and sounds in their head. But there are very specific counting concepts or counting principles that we learn, and there is a way of actually learning counting. There's like that learning progressions, and we start with my PowerPoint's playing up, but we start with the 8 counting principles. So I'm going to talk you through what they are very, very quickly. Then once they've had exposure to all of those principles, and throughout those principles, they're doing the count all. So that's the very first thing that they start when they're learning. They learn to count the entire quantity, and from that point, they'll start to learn to count on from a number. Then they'll count on from the larger number, so improving that efficiency and things like that. And then it's the trusting the count. So once they've learned that trusting the count, then they're ready to move into that next point which is the place value kind of thing. So this is the sequence of learning that students go through when they're learning how to count. But let's have a look at the 8 counting principles first, because a lot of them you'll be familiar with, and a lot of them you'll practice quite readily in your classrooms, but there are some of them that we don't really think about as commonly. The very first one is one-to-one correspondence. We all kind of know this one. It's when the student sort of has, if they've got 5 counters, they can put their finger on each one and they know that they've counted 5 and they've got that in the right sequence. So finger to manipulative or counter. Then there's the stable order principle, which means that students understand that 3, like if we've got a collection, that regardless of how we shuffle around that collection, we've still got the same quantity. So just because we've moved them from being in a row to being like in a circle, it doesn't change the quantity. So that's actually a learned concept as well. Then we've got cardinality, which means like as they're counting, if they've counted up to 7, that word 7 numerically means that there are 7 things there. So that's what 7 actually means. And you don't really think about these things as being a thing, but we kind of take it for granted because we know how to count, but these students are only just learning these things. The other one is order irrelevance. So the order counter doesn't matter. So I can start, if I've got them in a line, I can start from, front to top to bottom or front to back, or if I moved them around, I could start in the middle and I can go anywhere, but regardless of where I start in that collection, I've still got the same amount. So you can kind of get the general idea of where we're creating this understanding about quantity, about quantitizing, I guess. I've just made up a new word, guys. So students actually know or actually start to build that understanding about how many things are. Then we've got the ordinal. Ordinal is just like first, second, third, fourth, fifth, that sort of thing. So things are progressing in order and how to place, first goes before second, etc. Now, this one is one that I'm going to actually do a activity on to show you what this means. So abstraction, it's that counting that doesn't include the actual concrete. Okay, so they may be able to see things or hear things, but it doesn't relate to actual physical objects, not all the times. But also that if we've got things like I've got one of these and, one of these, I've still got, if this was a bigger, let's say one of this, how many objects do I have? I've got 2 objects. Like they're different things, but they're still 2. Those sorts of things is a bit more of that abstract thinking of counting. Then there's conservation of number. So the number of objects doesn't change even when rearranged differently. It's very similar to the previous one we discussed. And finally, supertizing. And I am going to have a whole sort of section discussion on supertizing, because supertizing is probably one of the most important things that you're going to need to work with students with. And supertizing can, utilize a lot of these 8 counting principles that we've discussed before. So this is an activity that I'm going to do with you, and I'm going to put the whole activity up. I don't think I have an actual worksheet or video on this, but once I put the instructions up, you can take a screenshot and you can have that. But it basically gets students to practice this idea of abstraction with their counting. So this is the activity. You can also do this. So we've got player 1 starts with a number card. So we play together. So we're starting with our starting number cards, and then we've got our action number cards. So our starting number cards are in a pile and they're from 1 to 5, and our action number cards are from 1 to 10. And you can vary those quantities depending on the age and the ability of your students, but this is what I'm starting with. So a student will choose, student 1 will choose a starting card. So I've chosen 4 as my starting card. I've just drawn it from a pile. I start with 4. All right, then player 2, so player 1 shows 4 on their finger. So you can see as we progress through this activity, you can see that both players are interacting with and practicing their counting. So player 1 has to recognize that they hold up 4 fingers for 4, and player 2 counts the number of fingers out loud, and they both have to agree that there are 4 fingers up. All right, now that will be player 2's starting number. So you can see that this is incorporating that trusting the count. So if students are not at the level of trusting the count, then you can just keep the 4 fingers up, or you can get them to use objects 1, 2, 3, 4 in front of them, because next they're going to choose, player 1 is again going to choose an action card. So my action card is 7, and 7 will indicate the number of times the action's going to be performed. So in my case, I'm going to be performing claps. All right. So player 2, the one who's doing the counting, will hold the number 4 in their head, or if they need to have the 4 objects in front of them, then they start from the 4 and player 1 will clap 7 times. Like that. And the second player, the one that's counting, player 2, will need to count on from that 4. But because it's not a physical object that they're counting, it makes it a little bit trickier. So that's where they're using their auditory sort of processing to count the number of claps. And it's actually quite a learned skill. And this is why when they're first starting something like this, you can just do it without a starting number. So you can do this as a class. So as a class, everybody's standing at the front with their whiteboards, and you say, all right, ready, I'm going to start clapping. And the students have to count that, write it on their whiteboards, hold it up for the correct response. And if you want to go a little bit deeper, then you start incorporating something called the number triad, which is they write the symbol 5, they write the word 5, and they draw a set of objects that represent 5. So getting them to practice that number in those 3 ways. So this is just a little bit of a nice little activity on getting that students to practice abstraction. All right. And, this discussion that happens afterwards is really interesting. I did this with my daughter yesterday. I said, let's play this game. And she's 23. So, not a baby. So as we were talking, I did the 4 and she counted, and we had this discussion. She's like, hang on, no, was that this much? Was that this much? So it's those discussions about number that build that reasoning and that communication in the students as well, which is super important. All right, next, we're going to be talking about supertizing. Supertizing, as I said, it's probably the most underutilized but most important concept or skill used in number. And I hope you guys can't hear my dog, but she's in the background. Apologies if you can. We are going to look at different types of supertizing. So supertizing, for those who are in perhaps secondary and haven't come across this word, because I hadn't until I started working with early primary, is the ability to instantly recognize numbers. So for example, if I held this much up, you wouldn't need to count my fingers. You would all automatically know that is 5. All right, so that's supertizing. But there are a couple of different types of supertizing. So the first type of supertizing is perceptual supertizing, and perceptual supertizing is what students sort of innately develop. All right, so it's almost like it's a evolutionary kind of developmental skill that we learn as humans to recognize numbers from 1 to 3. So very, very small quantities. It's part of our makeup. So when students come in to school, most of them will be able to potentially not, just depending on the how much exposure that they've had before, and to recognize quantities up to 3 quite easily. Now, the next part is conceptual supertizing, and conceptual supertizing is when they start to recognize composite numbers up to 5. So up to 3 is very straightforward for them. They can see that. The conceptual supertizing is when things start to get a little bit tricky for them, and they're going to start to incorporate their part whole knowledge. And then from that point, they start to recognize numbers up to 10. So that's obviously a much higher order skill for some of the students. I mean, it's a higher order skill for some adults immediately recognizing numbers up to 10. So you can see how involves a lot of practice, and it also involves a lot of visual spatial awareness. So building that visual spatial kind of response or skill in students is really, really important, because you want to be able to see that quantity. You want to be able to understand how to efficiently dissect those quantities into parts that you can actually recognize without having to count. All right. So conceptual supervising is this learned skill. It is actually not something that is people are born with. It's actually something that they have to learn and practice. So this is one of my favorite activities that I do, called dot plates. And you can take a screenshot of. I've actually got this file. I might send all of the stuff that I've got that is printable to Akriti at the end. But I'm going to do an activity called dot plates. And dot plates basically, it just involves, like, I just get these paper plates, and I use paper because it's recyclable and it's cheap. And I have a whole bunch of these patterns, and I just place them on these plates. So they're called dot plates. Now you'll notice that the very first one that I use is one that is less than 5. So this is if your students are very early learning, still kind of at that point where they just can't grasp that numbers beyond 3, then you would give them 3 dots. But you'll notice that they've got 2 colors as well. And the 2 colors are important because you will notice that the colors represent the quantities involved in perceptual subitizing. So 3. So we've got 1 and we've got 3 that make up 4. It doesn't have to be 3 and 1, it can be 2 and 2. But just when they're first starting, just make sure if they're going beyond 3, you give them that sort of that color, contrast for them to be able to recognize, okay, that's 3 and that's 1. So they start to use their very early addition and their part whole to recognize those numbers. So the way I do it is I would just, like any supervising activity, you would hold it up and you would take it down and you would say to them, how many did you see? So I'm going to do a dot talk a little later. So I'm going to give you the instructions now for the any of these dot talks, including the dot plates that I see. And they are that there is to be no calling out, there is to be no hands up, there's to be no writing, there's to be no nothing. All right. So for these types of activities, I want them to be able to verbalize their understanding, because that's really, really important. Communicating what they're understanding and their reasoning behind the strategies is also a developmental learned skill. So, and the reason why I say no calling out, no hands up is because it gives all of the students in the class an opportunity to process and be able to answer the problem without somebody else, because there's always, a couple of those students in the class who are always calling out, and they're the ones that always have the answer. So you want to avoid that just by giving an equal playing field. So you hold it up. So I usually just get them to put their fist to their chest, and when they've got their answer, they just put their thumb up like that if they've got 2 strategies. So this is representative of strategies. So I would hold it up, put it down, and the student will tell me what the quantity is, or they'll then write it on their whiteboard, or however you want to do it. Now you'll notice that the next level up, I would give them ones that have quantities that are partitioned into values that are up to 5. All right, so values up to 5, and then it is more complex values up to 10. And starting off with ones that are recognizable patterns, and then moving into patterns that are a little bit more random, which makes it a little bit more complicated and a little harder for them to understand. But dot plates is really, really good. Kids love it because of the colors, and yeah, you can move forward with that. So generally with the sequence of learning, and I talked you through this, but using those 2 colors, so we're starting with collections of up to 5. and then collections up to 10 where each color is less than 5, and then collections up to 10 with regular patterns, and finally collections where the dots are the same color. All right, so that's the sequence that you want to utilize when you're doing any sort of supertizing, not just the dot plates, just supertizing in general, unless it's something like a dot talk where you're getting them to do a slightly different skill, which is what we're going to do next. And again, I would usually, excuse me, I would usually do the dot talk physically where I would be writing on the board, but we're going to have to just make it work today. Hopefully it won't be too bad. So basically, in a minute, I'm going to flash up a pattern of dots up on the screen for 2 to 3 seconds. You can do this on a card, you can do this on a whiteboard, a projector, TV, whatever you want. So you're flashing up the quantity for 2 to 3 seconds, and then you put it down and you ask the students, how many do you see? Now, again, we're utilizing this strategy where there's no calling out. And then when we're ready, we invite the students to tell me how much they are, and write all of your answers on the board, because if there's an answer that's incorrect, then we can discuss what that misconception is with that. So the idea is you want the students to describe how they visualized that quantity, and you'll see why that's important in a minute. And you will then represent all of the student strategies visually on the board or screen. And I'll show you just very briefly how I work through that. I've got a video on this as well, and I haven't linked it here, but I will send that through after this as well. All right, so you ready? I'm about to put up some dots, and then I'm going to take them down. And then you guys are going to tell me afterwards, maybe in the comments, how much you think there are. Ready? 1, 2, fingers crossed. All right. What do you reckon? Anyone want to have a go? How many you think? I can't see the chat. We got 7, 7, 7, 7, 7, 7. Yay, 7. Yes, you are absolutely correct. It is 7. But, you know, I didn't have it up long enough for you to count. So I would like to know, and I don't know, this is the point where things get a bit tricky to doing it online, because I would generally ask people to invite me how they saw this. But I'm going to just role model how this would generally go in a classroom. So I would be like, okay, beautiful, it's 7. How did you see it? Okay, how did you see it? And then I'm going to see if I can annotate this, see how this works. All right. Let's draw. And somebody says to me, I saw it as a diamond, and then I saw it like that. All right. And I would draw that on the board with the name, and I'd go, beautiful. Hands up, big claps who saw it like this. Put it in the chat if you want to see it like that. And then I would ask somebody else, and that somebody else would go, well, I actually saw it like this. I saw the 5, and then I saw these 2 dots here. And somebody else will go, oh, yeah, I saw it like that as well. How many others saw it like that? Oh, I didn't, but I do now, you know, those kinds of things. And then you just keep going. Some people see it like this, 2, 3, and 2. And, you know, it's really just one of those activities. Someone might go, well, I actually saw it the same as the other person, but I saw it like that. And I did this once in a year 1 class with students, and I had these, not actually, these were prep, which is kindy, the kindy group, so about 4 or 5 years old. I had them going for the entire lesson. And what they would do then is, because I kept the dots up, they would start to see different patterns, and they would start to be like, I saw it like this, I saw it like that. And at one point, I think we had like 21 or 23 different versions of how the student saw this. And it's a really great way of getting them to practice this visual spatial awareness, because visual spatial awareness has been directly linked to mathematical achievement, because it's an abstract skill, as is mathematics. So, you know, developing those visual spatial skills is really, really important. And it has been shown to be, you know, developmental. So students are able to improve this. And in fact, a large part of the reason why they say that there's that discrepancy between boys and girls sometimes is because as young boys develop, they have a lot more access to sort of modeling and building and constructing things, whereas stereotypically girls not so much, although that is changing now, which is fantastic. All right, what do we got next? Let's see if I can this time. All right, we're up to place value. So place value, again, once you start, once you have consolidated student skills in their counting, they've gotten to a point where they can comfortably count to 20 and beyond. And I'm talking not just by rote, like not just saying it, like they've demonstrated it in lots of different ways. They've got a deep understanding, including part-whole relationships. They can trust the count, very important, and they can interpret and visualize numbers beyond tens in terms of their parts, because they recognize 10 as a countable unit. So just like they can count by ones, they can count by twos, they need to know now how to count by tens. So it will be ones, twos, fives, but 10 has to be seen as that, you know, unit that is also countable before they can successfully start to tackle this place value. Now, very importantly, I always start with this, proportional models versus non-proportional models, because in a lot of cases, from a developmental perspective, when students are learning how to count, when they're recognizing numbers, they need to see the entire quantity in order to know that regardless of how I rearrange it, I've still got the same amount. So if you're moving too quickly into non-proportional models, then it can pose a problem, create a conceptual gap there. And what I mean by that is proportional models are ones like, you know, unifix blocks or connector blocks, bundling sticks, you know, things that students can see the entire quantity. Like I know that there are 10 in here because if I pull them apart, they're 10 ones, but one of these makes 110, and, you know, there are 10 ones in this. So seeing the entire quantity, I even get them to do things like this. So the students actually make these. There are pony beads on just threaded onto a pipe cleaner, and each of the students makes 10 of those for themselves, and that becomes their little thing that they, you know, little units of 10 that they work with. So I've got in here, I've got, you know, 10, and so I can play a, you know, whatever game we want with those sorts of things. So very, very easy. If you don't have pipe cleaners, you could just use little patty pans or whatever. As long as you've got, the students have got the ability to have the counters or the models free, but then be able to be combined into one unit. Now, non-proportional models are things like money. I know this is worth $20, but it doesn't look like a 20 to me. You know, these red ones are worth, you know, 20, and each one of these are worth 5. So all of these things are non-proportional models that represent 5. So the blues represent a 2, and the yellows, the blues represent a 10, and the yellows represent a 5. Now I'm going to say one more thing about this. I'm going to talk about MAB. Because for me, I know a lot of people start with MAB. They start very early with MAB. And for me, I would say hold off on MAB until you know that the students have started to work with non-proportional models very, very well, true non-proportional models, because in my opinion, they are advertised as proportional models, but I don't think that they are, because here's what students see. And I've seen this, like I've asked the questions and the students have actually acknowledged that this is their thinking. So I have got in my hand, I have got 10 little ones here, 10 ones. Now these are even worse, the colored ones, because when a student sees 10 ones here and they're using something like a trading game, what we're doing is we're taking the 10 ones away and we're replacing it with this one stick. And the one stick, even though it's got the little notches on it representing a one, they don't see it that way. They see I've taken away 10 things and I've replaced it with one thing. So they don't have that conceptual understanding of proportion in terms of quantity, that unit. So hold off on MAB, go back to basics, start using things that they can actually pull apart physically and mentally. The other thing that I'm going to talk about is this versus this. If you've got, I don't know if you've got colored ones in your classroom, I don't know whether, right? So MAB block. So this is 1,000 block. Now, for those who have seen or have experienced both of these types of things, you feel the weight of it, right? If I was to put 10 of these, okay. So here are my 10s. Okay, here are my 10s. If I weighed both of those, they would weigh very, very differently. So this feels hollow. It's because it is hollow. So the students don't actually conceptualize that there is actually 1,000 tiny little blocks in these. So the plastic ones I would actually avoid. You know, use the wood ones because they are full. The volume, like it's actually a full block rather than the plastic. So these are just things that you don't even really think about, but are actually really important for students because it's so easy to develop these misunderstandings about place value and things like that. So getting them, so once they've been exposed to all of these proportional sort of models and they're ready, I'd get them to start, you know, moving into the non-proportional. Excuse me. So the other thing is there are two types of place value that students learn. All right. One is the conventional place value. And this is the place value where we know that we've got a ones column, we've got a tens column, we've got a hundreds column, and we've got digits in each column. All right. Very, very straightforward. By the sounds of it, it's not hard. It's not really hard. But students don't see it that way. When we use place value, when we introduce place value just using the conventional place value system, or we move past the conceptual very, very quickly because we assume that students know it, students don't see they don't see the value of the digit as they're working through. They just see it very kind of traditionally. It's like this is a 2 and it's in the tens column, so it's 2 tens. You know, so there's no deep conceptual understanding about it. So when we are working with place value, it's really important to work with it conceptually so that the students will then know how to unpack their numbers, and it encourages much more flexibility with their thinking. It builds that number sense. It builds that understanding of quantities. I mean, they won't, you know, be able to, like, they won't, you know, add 275 plus 130 very quickly in their head initially, like, you know, or using the vertical algorithm, but just initially they won't do that. But eventually, because they have that deep understanding, their mental computation will improve significantly. And that is what we're trying to do with our students. We're trying to build that conceptual understanding so that they can really build that number sense, that mental computation, and the fluency and the speed with that. So we really should be teaching the conceptual. And again, I'm all about starting with conceptual and ending with abstract, because the abstract is where the efficiency lies, is where that speed. We don't want to keep having to, convert move this into, the next place and bundle and regroup and all of that. But we do want the students to develop these processes and these algorithms, but not before they really have shown an understanding of the conceptual first. So when you're teaching place value, you do want to follow these sorts of sequences. So you want to start at that very first introduction, and then you want to move down these things. And I'm going to run through each one of these as we move along. So the very first one I'm going to talk about is positional property, because I believe that this is where a lot of the students in place value start to, this is where this is the make or break, right? And it's, all this means is the difference between face value and place value, right? So this is where the conventional place value starts to really take hold, because students will work through this. They'll be given perhaps something that looks like this, and they'll say, how many ones, how many tens, how many tens does this have? And a lot of the students will say, well, it has 2 tens, or they'll be asked, how many ones does it have? And they'll say 6, but it's not actually 6. There's 6 ones. There's actually 26 ones in this number. So that's where we start to develop that very fixed mindset with the students with regards to their place of the digit within the number. So place value, so the face value represents the quantity of the bundle. So here we've got 6 ones, here we've got 2 tens. The place value is the size of each bundle. There are 10 in each of these, 10 ones in each of these tens. So there are 20 ones here, and there are 6 ones here. So this is more of a conceptual type place value understanding. All right. To do this and to really build that well in the students, I always get them to use or start learning with the trading game. Before they do the trading game, I do have them working with tens frames and things like that. But once they've started to learn that, trusting the count and then moving beyond tens frames, this is the very next step you would go. So the trading game, and unfortunately, I'm not going to be able to demonstrate this one either. So, but I usually just get students to, I give them some dice. I give them a place value mat. So place value mat that looks like this on the screen. I give them some dice. I give them some isopole sticks. So you can use Unifix, any proportional model, doesn't matter. You can use the pony bees if you want, whatever you've got, as long as it's proportional, doesn't matter what you use. And then they work in pairs. One student throws the dice. Begin with a 6-sided die. That way they can sort of work their way up. So you start with a 6-sided die, throw the dice. I've just put down, I've thrown a 2, so I'm putting the 2 in the ones place. At some point, they'll keep throwing and they'll get to a place where they might have 11 ones in their ones. And so you get them to start having this conversation. Well, 11 ones, that kind of, what does that look like? Because you'll notice at the bottom that I've got digits under here. So anytime the number changes, the students are writing the quantity under here as well. And that's because when they get to something like 11, they'll realize, well, I've got 11 there, but 11 is actually 1, 10 and 1, 1. So we bundle together and we regroup. So we move it into the next place up. I get them to do this on a laminate some printed A3 boards, and I give it to them and they just write on their laminated A3 board, or you can just get them to use post-it notes. But post-it notes, you're going to have to throw that away. It's better to use something that they can rub off. And then they continue playing this. Now, at some point, they'll get into the hundreds and they'll go, well, I've run out of sticks. Right? Because once they've gotten up to, so you'll start them off at 1s and 10s, obviously, give them the appropriate board, and then we move into the hundreds. But if they've got 9, or even they've got, 600s, they've run out of, I suppose, sticks. They need another one. They need more sticks, and they come to you and they're like, we need more sticks? And I'm like, well, we don't have any more sticks. Like, what do you think you're going to do? And in many, many, many cases, in fact, in almost every case, I'll have the students say something like, well, what if I make like the blue can be my 1 and the orange or whatever color will be my 10, and I'll make the yellow my 100. And so they have automatically moved into that non-proportional model because they've started to develop that conceptual understanding of quantity, how much this represents. This is a 1, this is a 10, this is 100. So you get them, when they're ready, they will automatically move into that phase. And it's actually quite beautiful to watch. So trading game, it's all over the internet. You can find it anywhere. But yeah, that's my little spin on that. Then we've got the additive property. So the additive property of place value is this idea that the numbers are partitioned into all of their different parts with their value included. All right. So this concept of the sum of all of the parts make the original number regardless of how it's partitioned. And I have just very simply, this is an activity that I do with the students. This is actually an exit ticket after I perform like whatever activity we've done on the day. So as an exit ticket, I want to know whether students have understood the concept. So I'll give them this and I'll say, complete the table for this roll of dice. And I'll give you the instructions for the activity that I do. So if you have, I've rolled a 5, a 6, a 2, and a 5, and a 3. You can put those in any arrangement you want, but you need to complete this table. So let's start our number. First 3-digit number will go not 5, because here we want them to put it in expanded place value form. So they will write 50, let me annotate this. They will write 53 here. So they'll be 562. I'm writing with my mouse. So then this will be 500. This will be 60. And this will be 2. And so you're getting the idea that the students are recognizing both the place value here and the face value here, and they're making that connection. And they'll do the same thing here, and then they add the numbers together. So if we go to the next slide, I've completed this, and you get it to complete it. And because it's an exit ticket, I want them to show and explain their method. So let me just rub out this annotation. All right. So 562, they've got that. 53 is their next number. They write 53. It's very important that they put this 0 in, because 0 represents a place value holder. There is no value in that place, regardless if it's here or if it's in the middle or if it's at the end. And then because we are so quick to move into that vertical algorithm to add, I've placed them above each other. And so the students can add, they can still add down the page. So they've got 2 and 3 makes 5, 60 and 50 makes 110, and 500 and 0 makes 500. And then I've got this number over here, 500 plus 110 plus 5. If I add all of those values together, I'm going to get 615. But I also can do it in a different way. I can, instead of saying 500 plus 110 plus 5, how else can I do it? So what you're essentially doing is you're regrouping this number here. You're taking 100 from that and you're putting it in the hundreds place. So now you get 610 and 5. Or you can just, do it that way. So this is sum of the two numbers together, this one and this one, just allowing them to use different strategies to solve the same number, because you're trying to build that flexibility with their number. And this is the whole idea of that additive place value, so we're breaking, and it works especially well with subtraction, especially when you've got a number like 560 minus 997. We're going to have to regroup more than once. So that's the idea about that sort of additive type thinking, where they're partitioning their number into their actual place value and working through that. So that's that activity there. Sum it up, right? But there's another one, and I've got 10 minutes and I'm nearly done. This is I love this activity. This is the same concept, but it is a little bit more of a problem-solving task. So it utilizes this idea of all of the different parts as you're adding numbers. So the challenge is you choose 6 numbers. So you're choosing the numbers because you're then reasoning what number or what digits can I place in this box here that's going to allow me to get as close to 1,000 as possible when I add. Now, the trick is, though, you're not just adding horizontally, you're also adding the digits vertically. So in this example here, we're adding 486 plus 132 plus 41 plus 83 plus 62. All right, and we want to know, what digits am I using to get as close as possible? Now, I can use those same digits and I could go, all right, well, 486 didn't work, but what about 864? Because that's, 800 is a larger number. There are 800s here now, and 132. Let's keep that as is. And 864 plus 132 plus 81 plus 63 plus 42. I can see I've probably already gone over the 1,000, so that's not going to work as well. So the students will then use their reasoning while they're working with their place value, and it's addition. And in this case, addition, you can change it. You can say, I want you to add horizontally. I want you to subtract. I want you to use 4 different operations to try to get as close to 100. But it's in these types of activities, what you're trying to encourage is encourage that understanding about numbers conceptually, where they're pulling the number apart, and you're wanting the students to recognize that the digit is not just a digit. This here is not just 8. That's not 8. That's 800. All right. That's not 6. That's 60. You know what I mean? So when you say what is in the tens place here, you say there are 3 in the tens place, but that represents 30. There are 3 tens and there are 30 ones here. So if I said 864, how many ones? How many ones? 864 ones. How many tens are there? There are 60 tens in here, in that number. So that's the kind of language and that's the kind of understanding you want to develop in those students. All right. Now, let me just rub this out. All right. Now, finally, we're moving into our final kind of bit of understanding, and that is the base 10 property. So the base 10 property is more multiplicative. All right, so we've moved from that additive component of place value to that multiplicative component, which is as we step to the left here, as we move to the left, our numbers get bigger. And as we move to the right, they reduce by 10, by a value of 10. And again, it's that whole idea of multiplicative thinking with place value, where the face value of each digit is multiplied by its place value. So if I have the number 1,726, the 6 here is actually multiplied by 6 to the power of 10, multiplied by 10 to the power of 1. The next is the 2. The 2 is multiplied by 10 to the power of 1. The 7 is in the hundreds place, so 3 times 10 to the power of 2, 3 times 10 to the power of 1 times 10 to the power of 3. So you can see it's that whole, the base is 10, the power is increasing by a factor of 1 each time. And it's the same with division. Now, this is a really important concept, not just because we're increasing by powers of 10, but we are also decreasing by powers of 10. So when you're moving down that sort of scale across the value, you're now moving below 1 into your decimals. We now divide by, so we're now multiplying from 10 to the power of 0, we're now multiplying by 10 to the power of -1, by 10 to the power of -2, by 10 to the power of -3, which is like a tenth, a hundredth, a thousandth. So getting the students to understand that scale is really important as well. And the final, this is the final one that I've got. And all this is again, just getting them to, oh, we've got 2 minutes. Number chairs, roll the dice, give the students a number, tell them to sit in whatever position, do it, multiply, roll another multiplier dice. Like I'm now multiplying by 10 to the 2, or I'm multiplying by 100. How are we moving along those chairs? So we're moving left 2 places, and we're adding zeros into those things. So it's called number chairs. It's a really great way, especially when you've got a decimal place, because they see how the digits move across the decimal. The decimal does not move. The digits are what moves. And that is it. Whew. Final takeaways. All right. These are your final takeaways for today. I hope that you took at least one thing out of today's session. And thank you very much for having me, everybody. I've really enjoyed my time. You've got like 2 or 3 minutes for questions. I'll stop sharing.
It was surely a very wonderful session. Now we open the chat box for all the questions. So all dear participants, I request if you have any questions, please drop it in the chat box. If you have any questions related to activities, the discussion that Nadia has shared, any questions that you have, please drop it in the chat box.
Thank you, everyone. Lovely messages. Okay, we've got a question very quickly up here. If a student is a slow learner, then which model do you think is best to teach the place value? Definitely the trading game. So there's another game that uses tens frames. So you want to start with a tens frame. It's called the tens frame game, where I've got 3 tens frames on there, and the student rolls the dice, places their counters, so different colored counters, so they can either work in pairs, where one student may have red and the other student may have blue. So the idea is that they are building up to that that unit of 10 and being able to work with their partitioning of the numbers up to 10. So you really want to get them to practice. So when they're playing a game like that with a tens frame, you want to make sure that they consolidate their understanding by writing down their thinking. So I always get them to use something called a number triad, which is just broken up into 3 parts. They've got object, symbol, and name. And so whenever they're creating a number, they are writing the number down as a symbol. So let's say it's 5. They're writing it down as a name, like 5. And then they are drawing a representation of the number. So it could be a tens frame. It could be just some counters. So getting them to practice those things in all of those different ways, it's really, really important in being able to verbalize. So it's just more and more and more exposure and practice. Yeah.
We also received one more question.
Yep.
Because it's the very first session of our mathematics summit, and I feel it's the very important question. Somebody has asked how to make our students more interested in mathematics.
I think you have to be interested in mathematics to get the students excited about it. I always go in, maths is, it's interesting, exciting. Start with a hook, start with a story. So when I developed a curriculum for a school, without fail, everything that I began with was something that would build curiosity in the students. For example, if we're doing time, I would bring out I'd tell them the story of a sundial, or we discuss the history of time, or, we just something to get them motivated and engaged in it, because maths can be very dull, but it can also be, it's super interesting subject if you really dig deep. Anytime you want to get student engaged, you've got to spark their curiosity. That's what you've got to do. So making it into something that they can relate to, they can engage with, is really, really important, especially for the students who don't have that natural ability, or they're coming in at a much, at a disadvantaged level than other students. You've got to engage them physically, like sight, hearing, visual, tactile, using their body, immerse them in the beauty that is maths, not just the traditional, like, here's some sums, solve it. Like, who cares? Honestly, somebody gave me 2 + 2 on a paper. I don't care about that. I want to know something that's interesting to me.
Right, great. So we are getting a few more same question, how we can make learners. So I believe Nadia has explained different strategies, how we can change our body language also. So let's move towards the closing of our first session. Miss Nadia, it was truly a very enriching, full of strategies and hands-on experience session for all of us. We are very thankful for the information that you have shared with us, and we are also receiving very positive feedback from all the participants. Now, thank you so much. And to all the participants, if you would like to revisit this session, please go to our YouTube channel. You'll have the link. We have also dropped the link for the specific session. You can revisit the slides, activities as well. So with that, let's move on to our next session, which will be scheduled at 12 p.m. today. So make sure that you are tuning in for that also. And
thank you, everyone. Bye.
Thank you, Nadia. To all the participants, for the feedback form or certificate, you will be receiving an email on your registered email ID by Monday. So you can fill that feedback form and you'll receive your e-certificate. So thank you so much, everyone. Thank you so much, Nadia. I'll see you at 12 p.m. Thank you.